Web development uses a lot of tools. I mean, the JavaScript tooling is almost a meme these days. If you're new to development, learning all the stuff that's needed is not an easy task. If you haven't encountered what can go wrong, it's hard to understand what different tools even are for.
Things become buzzwords like server rendering, Tailwind, Next.js, Svelte, a virtual DOM, compiling frameworks, Typescript, state management, MPA, SPA, etc. Like, one can just accept that there are a bunch of different tools and use what others use, but if we understood where things started, what problems that were encountered and why things were invented, navigating the tooling space of the web will be a lot easier. So in this and the next video, I will take you on a tour from the foundation of the web to the modern tools that web developers use today. See this as a derivation of why tools exist and why it may be helpful for you to use them. This will be easy at first, but will get more complex towards the end. Let's go. If you're navigating the web, you're using a browser, so let's start there. A browser does a lot of things, but the two main ones are to display content and handle inputs. The content of a web page is usually just a combination of simple shapes and texts. And to create a website, these shapes need to be specified for the browser in some way. We need some kind of document that humans can write and browsers can read. For this, HTML was created. It's a protocol or language that specifies the content of a website. A browser can read HTML and paint the desired content. Now, even if things are just simple shapes like a rectangle, they can still vary a ton in different designs. So, to just give the browser a HTML document might not be enough to precisely specify how the browser should paint our content. Therefore, another type of document called CSS was created, so that we could specify the styling of our basic shapes to the browser. Are we done now? Do we need anything more? Well, actually just one more thing, but in practice, probably a lot more. The other main thing that the browser was responsible for was handling inputs. Neither HTML or CSS are made to specify actions or logic. If you want to show something with a click of a button, the browser needs some more information. This specification is done with JavaScript. These together, HTML, CSS and JavaScript, are the three components to specify the look and behavior of a web page. We could, with this, create a fully functional website and settle here. However, we usually don't. There are a couple of problems. The first might be reusability. Let's say that we want to build a button. We want it to have a specific design. It should have some animations for hover and click. We also want to specify what should happen when the user clicks the button. Now, since we want a uniform design for our page, we want a similar looking button in other places as well. So we copy the code and place the duplicates where we want to. What's the problem with this? Well, what happens if we want to change the button in the future? We will need to change every copy, since they are not connected in any way, they just happen to look equal. If we forget to change one, we will also not be notified by our editor, because it can't know if we want to change all of them or just almost all, so it's easy to make mistakes. Another problem with duplicating the source is if you don't know how many times to duplicate. Let's imagine that we have a page that displays products. Every product is displayed with the same layout but with different information. This layout, like the button, is made of HTML, CSS and JavaScript. So how many times should you copy the code? Well, that depends on how many products we want to show. But the problem is that we may have 10 products today and 12 tomorrow. We therefore can't make a static amount of copies. These composed layouts, like buttons or product cells, will from now be called components. A component is basically structure, styling and logic that is grouped together, often for reuse, but sometimes also just for organization of code. Okay, so how do we solve these issues? Well, we can specify logic with JavaScript. So what if we create a function that can generate a component for us, for example a button? If we did this, we would have a single source of truth about how the button should be. And if we change the function in the future, it would change the button in all places. It's also a lot less code to call a function instead of duplicating components. This would also allow us to generate an arbitrary number of copies, since we in JavaScript can use a for loop to call the function. So this might be a solution for both our problems. However, people have already faced these problems before us, so they have tried multiple different implementations for this, and by trial and error and much thought, the solutions have converged into component frameworks that we can use today, so we don't have to reinvent the wheel. The most popular solution today, and also one of the earlier ones, is React. With React, we can compose components in a way that feels a lot easier than creating them in raw JavaScript, just like we had wished for. However, when inventing an abstraction for reusability, two more questions were probably asked. Question 1. Since we want logic to calculate a layout, just like in the problem of number of product cells, how could we make it intuitive to mix HTML and logic, such as for loops or if statements? Question 2. If something should be able to change on the website, let's say the number of products, a navigation menu, or a counter, how should the programmer make those changes happen? How did they solve question 1? HTML was created to easily specify structure, and it works great for that. But now when we want to use JavaScript to generate the layout, we can't simply write HTML in our JavaScript file. We could create HTML as a string and then insert it to the browser with JavaScript. However, this will not be a great experience since our JavaScript checker will not give us any feedback about mistakes in our HTML string. So, to solve this for React, a new file format was created called JSX that accepts both JavaScript and HTML. With that, we can then mix HTML and logic to create components. This solves the problem with dynamic layout, and it keeps the ease of specifying layout with HTML. Now for question 2. To update content in the future, one solution could be to keep references to the elements in our code. We can then use the references to manipulate elements in the future. However, this is not the solution web frameworks converged into. Instead, they chose to create a reactive approach. With this, elements are updated based on when data changes. This means that we don't need to keep a reference, we just specify what data should be used to lay out the component. And when that data changes, the framework is responsible to update the UI. So, why did they bother to go with the second approach? It sounds very nice that the UI simply reacts to the data, but it's clearly more responsibility for the framework, and if the framework doesn't update the UI well or isn't performant, it can be more trouble for us to fix it. Well, to solve a problem in one way or another is sometimes just about preference. But the reactive approach is basically standard now, and I'm one of many who likes to use it. So my guess for its popularity is that reactiveness plays very well with the declarative syntax of HTML. What do I mean by that? Well, in HTML we don't tie elements to a variable or something, so creating a reference always requires extra steps with IDs. So to keep the nature of just stating structure in HTML, reacting to data is a very intuitive solution. Okay, so the reason for a component framework like React is now kind of clear. But since React was developed, a lot of new frameworks have been released. So the question is, what did they think they could improve on React solutions? Well, to answer that, we have to dig a bit deeper into that magic reactiveness. A browser has something called a DOM, a document object model. It's basically a representation of the content of the web page. So to change the content in the browser, we need to change the DOM. So the question becomes, how does React change the DOM for us when our data changes? Drawing our HTML elements in the browser viewport will from now be called rendering. Drawing complex layouts can be resource demanding, especially if it happens frequently. Because of this, we want to re-render as little as possible when we change the data. In React, when we store data that should update the UI when changed, we get a set function. By using that set function, React knows that some data has changed in the component. When used, React could just redraw the entire component with the new data, but that would not be effective. Instead, to just update the necessary elements, React uses something called a virtual DOM. What the heck is this, you may ask? Well, the virtual DOM is just a copy of the browser DOM, also called the real DOM. Okay, that feels like a bit of overhead, doesn't it? Well, yeah, but actually, no. It will speed up some things. When the setData function that I mentioned earlier is called, React can use that virtual DOM copy to calculate how the change of data will affect the content in the browser. And this calculation can be done without triggering any re-renders in the browser. Then, when that calculation is done, React can efficiently request the browser to redraw specific things instead of the entire component. Pretty smart, huh? That is the basic idea of the virtual DOM. React is therefore using resources to calculate what to update using the virtual DOM, but is then saving resources when only having to re-render specific parts of the page. And so the idea is that this extra calculation and comparison using the virtual DOM is worth it, and in total is faster than not doing it. And this idea seems to be true. From now, how a component is at a point in time is called state. In web development, when data changes and a component is re-rendered, it's often said that the state changed. The method to efficiently update the state of a component is very important since websites and web apps are used by almost everyone every day. At every little click or input, this state management is likely used, so squeezing every bit of performance there is to get might be reasonable. Then, is there anything we can do to make this even more efficient? Well, even though the calculating first, re-render later approach with the virtual DOM is faster than not doing the calculation first, it would be even faster if we skip the calculation part but got the specific re-render anyway. Well, that seems kind of impossible. How could one have a calculated efficient re-render without doing the calculation? What if we reimagine the idea of how the state should be handled? In React, there is a program as a middle layer that is responsible for state changes. But maybe we could delete that altogether. Okay, but how should any of it work then? Let's imagine that we instead build something like a compiler, something that takes our code and composes it into a ready web app. Now, what if, when that compiler is composing our app, it also generates extra code which takes care of all the updates that could happen from our source code? That would mean that we don't need a mid-layer program which compares changes to make sophisticated updates, because instead our compiler has already generated code that takes care of making the sophisticated updates. So what seemed to be unreasonable is kind of not, because with this we have precise re-renders without the calculation. Now, talking about a hypothetical solution is only relevant if it's actually buildable, because initially, at least to me, this compiler does not seem trivial to create. But it has been built, and the most famous project and probably the first to do it is Svelte. Svelte is an alternative to React and does approximately the same job, but in a different way. The fundamental differences in state handling between the two could be summarized. React provides a program included in your web app that handles your updates. Svelte, on the other hand, transforms your app into a reactive machine. There are multiple frameworks to choose from, and those are only two of them. I chose to talk about Svelte because of its fundamental difference in rendering, which brings an interesting contrast to React. React and Svelte differ in multiple ways, so even though Svelte is faster, the decision what to use is more complex than just speed, and more factors need to be considered when choosing a framework. We have now covered the fundamental idea of a framework and its responsibilities. Our goal is to find the tools that are sensible to use to provide a modern web app. And so, do we have what's required? Do we need anything more? Well, let's see. We begin building our app, we create some components, add some logic. It seems to work. To ensure that the app is doing what it should, we do some tests. Click, 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 click. What is this? It should just count up. But that isn't what's happening. The code looks alright. Come on, what's wrong? The editor doesn't show any errors either. Well, unfortunately, the problem was that we had provided the wrong type of value for the argument. But in JavaScript, we don't provide any type annotation in our code, so the editor couldn't help you either, because you hadn't simply specified what type you wanted in your argument. Now, this was just a basic program. With some troubleshooting, you could pretty fast find the problem and fix it. But in a real product, the code will not be this simple. You might have multiple abstractions and hundreds of functions. So to make this more scalable, we might want to add some additional tool to use in our development. Well, what could that be? The browser doesn't understand anything other than HTML, CSS and JavaScript, and only JavaScript is made to specify logic, so we can't just decide to use another programming language that does specify types. Or can we? Maybe there could be some kind of programming language that does specify types, but then when we compile our app, it generates JavaScript from this language that could be sent to the browser. That doesn't seem totally unreasonable. With this, we could write our code in this other language that does have types, that will warn us if we provide the wrong types, that can provide abstractions so we don't have to remember everything ourselves. And then this is translated to the language browsers can understand, namely JavaScript. Since type checking is done in the editor during coding, translating the code to a language without strong typing, like JavaScript, won't be a problem, since our logic was checked before translation. Okay, but this seems kind of complex to build, and not something that we would build for a single project. But luckily for us, this has been a problem for many others as well, so a ready solution already exists, and its name is Typescript. So Typescript is a language that we can use to make the editor warn us about mismatches in types and some other problems. This helps us with the problem that we had previously with the button not working, and so we decided to use that instead. All logic is now written in TypeScript files, and the React.jsx files we talked about earlier do have an equivalent called TSX that we use instead. Now, it's worth noting that TypeScript is not in any way mandatory to use. We could, if we wanted, continue to use JavaScript. However, to make development more scalable and more predictable, many prefer to use TypeScript. We now start to feel pretty robust in our tooling. We can build our app with reusable components, we can efficiently mix logic with HTML, we can efficiently handle updates in our components. We now also have a more competent analyzer that, when we write our code, can warn us about even more problems that we might cause. But one thing that we haven't talked about is the best possible way for us to manage our styling, the CSS. As stated in the beginning, the CSS is usually written in a separate file. When we write components, the styling needs to be bound to the correct elements in the component. Managing that binding can slow down the development because you will need to come up with unique and logical names for all the different stylings. The names also have to not collide with each other. Another problem with CSS files is that they can become quite long and scrolly, which also slow down the development. Are these problems something that can be improved? Well, many people have been working with CSS for years, and so many solutions for this have been created. Stating the best one is a bit about preference, but my favorite solution, and also favorite for many others, is called Tailwind CSS. What Tailwind does is that it has multiple short, concise classes representing common stylings. These classes are then used directly in the component, in the TSX file or Svelte file. When we build/compile our app, Tailwind generates CSS files for us that can be sent to the browser. With this, we can style our elements directly in the components. We don't have to create a separate CSS file. The biggest advantage with this is that we don't have to bind elements with styling. So the problem with names stated before is then solved. Another advantage is that these pre-made Tailwind classes have short and easy to write names. The downside with this approach is that our components do get a bit cluttered with these classes, and so it's a compromise, but a compromise many are willing to make. If you're using Svelte as a framework, using regular CSS is actually not a bad choice, because in Svelte files you can write styling directly. You don't have to create a separate CSS file. In Svelte file, CSS is also scoped, which means that it's encapsulated to a specific component. CSS names will therefore not collide between different components in Svelte. These two things make it much nicer to write regular CSS in Svelte. When I'm using Svelte, I therefore often mix Tailwind and regular CSS in the same component. I specify simple and repeating styling in Tailwind and write more complex stuff in regular CSS. I will end the video here. This was part 1 of 2, and the explanation will continue in future video. I will in that one derive the reasoning for many of the remaining web tools and strategies. Hope you liked the video and maybe you want to subscribe for the next one.